go to page 11 on your notes. Woo. Including what we talked about Friday, which is the area of a regular polygon. But Ms. Jenkins, you told us we were done after 11.3. Yes, I know, and I didn't lie, I just forgot. I didn't lie, I just completely forgot that there's 2 sections to 11.4. One of them being this scary thing called the apothegm. Okay, so first period, like last week with y'all, when we first did this, they were like a possum in headlights. Okay, and today they were like, for some reason this doesn't seem as bad as Friday. And I'm like, it's probably because we did one problem Friday that took us 7 minutes. And so now, like, the hard part's over with. Like, you know what's coming, right? So they agreed that it was a little bit better today than Friday. So name a polygon. Name a polygon.
Nonagon.
Pentagon. Nonagon. Decagon. Dodecagon. Triangle. Octagon. Hexagon. All of those. I don't know. Okay.
Good morning.
Okay. I can come down there. I can come down there at the beginning of 4. Alright, so all of those shapes that you just told me about fall under this same formula. Do you think this formula is going to be on your test on Wednesday, your quiz? Yes. It's going to say, what's the area for a regular polygon? You have to remember the importance of the word regular. Because, first period, they said, well, how do we know all of these sides are the same? Because it's a regular polygon. Regular polygons have all of the same sides. Okay? So, in order to find the area of any regular polygon, you have to have 2 things. You have to have little a and big P. What's little a? Apothegm. What's big P? Perimeter. What's big A? Area. So we actually got to number 1 on Friday, right? Okay, you didn't get done copying. Let me talk you through number 1 again. Okay, because we all need a review. I don't care who you are, you need a review on this. Okay? So, they only gave you that this whole side's 14, which means this is 7 and this is 7. So it was easier for us, we didn't finish it, we just started it. We found the perimeter, because if this side's 14, then so is this and so is this. So 14 times 3 is, I think it's 42? 42. Okay, 42. So we have big P. Your apothegm, that word, is anywhere from the middle of your shape straight down. So all of these 6 examples, your apothegm is the dashed line. See it? Middle, down, middle, down. That's your apothegm. So in this case, we need to find this little piece right here. How did I get, so what I did is I broke this into 3 pieces. You'll always break it into the number of pieces, which is the number of sides. Does that make sense? Let me say that a different way. There's 3 sides in this triangle. So I can break this into 3 pieces. Okay? The reason I'm breaking it into 3 pieces is because this is a circle in the middle of this triangle, which means there's how many degrees in this whole circle? 360. Isn't there going to be 360 in every single middle of a polygon? Okay, so if I broke it into 3 congruent pieces, it makes this piece 120, this piece 120, and both of these 120. But I'm going to enlarge the apothegm. This is your apothegm. What was the measure of this side? 7. 7. And then if this plus this other side made 120, then just this one is 60. This is 90, and this is 30. Now, you can do two things. You can use special right triangles, 30, 60, 90. If you don't like special right triangles, you can use tangent. It's still going to work. This is tangent of 60 equals 7 divided by your apothem, which is also your adjacent. So tangent of 60 equals 7 divided by x. When x is down low, switch them, you know. So now we're going to have, this is your A. What was it? What was 7 divided by tangent of 60? 4. So we have your A and your P. So area is equal to 1/2. Your apothem is 4. Your perimeter is 42. Which gives you 84 meters squared. Okay, let's do number 2. Yes, if you use this angle. If you use this angle, you will always use tangent. Okay? Okay. So if this is 10, then what's this? 10. All 10s, right? So it makes your perimeter 50. Makes your perimeter 50. Okay, now we need to find this piece right here. This is your apothem. That's what we need to find. I need to figure out, first of all, if this whole thing is 10, then this piece is, and this is, okay. So I'm going to enlarge that piece. You don't have to do this. It's just a thing I like to do. Okay, so how many degrees are in the whole middle of this pentagon? How many pieces can I break it into?
5.
There's 5 sides. Where do you break it? You take it to wherever the two sides meet. So wherever there's a corner, that's where you can divide it. So if there's 360 degrees divided by 5, that means that, okay, thank you. Each one of these is 72 degrees. Okay? Then, if you break 72 into 2 pieces, it's going to be 36. So, both of these are 36. So this is the one triangle I want to work with. This is this triangle right here. 36 and 5. And I'm going to put an A here. Why am I putting an A here instead of an X? We're finding the apothem. So I'd rather just call it A so you know exactly what I'm talking about. Okay? Alright, so using tangent of 36, that means this is your O and this is your A. Tangent of 36 equals opposite divided by adjacent. Adjacent, but A is the apothem. Okay, A is down low. Switch them, you know. So A becomes, which is equal to, let's say 6.9. So big A is found by taking 1/2 times the apothem, which is 6.9, times your perimeter, which is 50. Huh? No. Okay, so I'm going to give you a few minutes and let you finish 3, 4, 5, and 6. But I want you to notice something. 3 is just like 2 and 1, so is 5. But 4 and 6 are a little bit different. What are you given in 4 and 6? You're given the apothem. Oh, good. It'll be easier. Well, what do you have to find? You have to find the perimeter. So let me walk you through just a tiny step of 4. How many sides are in 4? 6. Okay, so divide it into 6 sections. 1, 2, 3, 4. So that means 36 divided by 6 is 60. So each one of these are 60. Which means you're always going to use the same portion. Like, I'm always going to use this triangle. So if both of these are 60, that means that this is 30. And I know this is 5 squared of 3. So that's 30. This is 90. So this has to be 60. Well, think about this. That's your leg, right? 5 divided by 3 is across from your 60. That's a leg. So what's your short? 5. Which means this piece is 5. So what's this piece? Which together makes?
10.
Which makes your perimeter?
60.
You got everything you need. Okay? Take a few minutes and try to finish 1 through 6. I'm going to write my answers up here so you can check your answer. Even if you're not done, we got to move on. Okay? So, are there any questions on these that you got to finish? Okay, we got to go to the back because there's a whole different part to lesson 4. This part's not bad. You already know all this. So what we're doing, these are called composite figures. So you're taking different shapes and you're finding the area of the whole thing or pieces of it, etc. So if you look at example A, you're only finding the area of the shaded portion, which you can't really see up here, but if you look at your paper, it's just this portion right here. So my advice is to find the area of the whole thing and then subtract what you don't need. For example, this actual whole shape is a rectangle, right? Find the area by doing 50 times 30, which is where they got, I don't know, 1,500? Yeah, 1,500. Okay, well, if I find the area of this half circle, what's the formula for circle? Pi r squared. Well, what's the radius of that circle? 15. Why is it not 30? 30 is the diameter. The radius is 15. So after I find 15 squared times pi, that's the whole circle. What do I have to do? You have to divide that by 2 because that's a half of a circle, not the whole thing. So divide that by 2. So your area of this circle is 353. So you take the whole thing, subtract 353, and that's how you get your answer. For example, B, you want to find all of these shaded pieces. Well, that would be really difficult if you didn't know what you know. Right? What's the whole shape, Intel? A rectangle. And it tells you that it's 10 by 30, which makes 300, right? Okay, can I find the area of one of these circles? The area is pi r squared. The r is 5. 5 squared is 25. So the area of one of these is 25 pi, but if there's 3, then that becomes 75. That's where they got 75 from. 5 squared, which is 25, times pi, but there's 3 of them. Multiply it by 3, which is where they got 75. So 300 minus 75 gives you the shaded pieces. Where? Oh. It's supposed to be 25. Okay, so let's look at number 7. We're finding the whole area. We're not subtracting anything. Okay, we're finding the whole thing. So I personally like to write the area of each one in the shape I'm finding. So this one is 15 times 34. So I'm going to write it here. That tells me that I found just that shape. Does that make sense? That's just a me thing. You don't have to do that. Okay, well, what's the radius of this circle? 7.5. So you're going to find this area by doing 7.5 squared times pi divided by 2. Why am I dividing it by 2? It's a half of a circle. So I got that this area right here is 88.4. Now what do I have to do? Add them together. 510 plus 88.4. Your area is 598.4 feet squared. Okay, so what I want you to do before you come back in here on a Wednesday, you still have 3 minutes, but I want you to finish, if you didn't finish page 11, these, finish those, and then finish all these on page 12. I need to give you a hint for number 8, though. Jay, Isabel figured it out. That doesn't surprise anybody. We don't even have to find this piece and this piece, because watch this. If I draw a line right here, all of this can be cut out and picked up and placed right there. So really, this shape becomes not a weird shape, but a rectangle.
Nice.
Do you know how long I worked on that problem? So this becomes a rectangle that has 40 inches by 24 inches. Do y'all see how that makes, like how if I could cut out this bottom piece and I pick it up and I glue it back down, if I glue them together, it's just a box. And I lost sleep over that. And Isabel figured it out in like 10 seconds. It's okay. That's why I'm a math teacher and y'all are going to be engineers.